Okay, so this is summation notation, and this little figure here is called a sigma, and this is I. This is going to be your variable. So what you have to do is solve, and your I is constantly changing, so you have to plug in your I to the formula given. And so you start with your I, which is 3, and then you move up until you get to this number, because this is how many terms you need. Once you plug in your formula to everything, you can go ahead and solve, and you get negative 364. Also, the difference between arithmetic and geometric summation and notation is arithmetic is addition and geometric is multiplication. The difference between geometric sequence and arithmetic sequence is the multiplication of the same number and the addition of the same number. And here's an example of arithmetic sequence. So we're going to find the 150th term, and the first step is you have to find your common difference. So you have to see what's different between all of the terms given, and you have to figure out which formula you're going to use. So in this case, we're going to use an equals a1 plus n minus 1 times d. So n equals the number of terms you need, a1 equals the first term, n equals the number of terms minus 1, and then d is a common difference, which is negative 5, because you're subtracting every time you move to a different number. So once you solve, you get negative 736. Okay, so this is an example for geometric sequence. We're going to try to find the 30th term. So we see that within all of the given terms, it's times 4 to get the next term. So we're going to use an equals a1 r to the power of n minus 1. So n equals the number of terms, a1 is the first term, 4 is the difference, and 30 is the number of terms minus 1. Plug in all your values, and your 30th term is 8.65 times 10 to the 17th power. Okay, so we want to find how many rounds it would take for 300 million, aka the population of the United States, to be involved in a pyramid scheme. So one person recruits 3 people, and then those 3 people recruit another 3. So that would mean our common ratio is 3, and this is a geometric series. So the sum is 300 million people, and our a1 represents our first term. So we would use the geometric series formula, which is Sn equals a1, 1 minus r to the power of n over 1 minus r. Okay, so our first step is to plug in our values into the formula, and then we divide by 3 on each side to get rid of the denominator on your right side of the equal sign. So then you're left with 100 million equals 1 minus 3n over negative 2. And then to get rid of that denominator, you're gonna also want to multiply that by negative 2 as well. Then once you're done with that, you simplify, and then you want to get your number and your variable by itself. So you're gonna subtract negative 1 on your right side and do it to the other side as well, and then you get 200 million and 1 equals 3. You get 200 million and 1 equals 3n. You want to plug that into a log. So you're going to have log 3 to the 200 million and 1 equals n. And then you're going to solve your logs, and then you're going to get about 17 rounds. So in order to find the percentage of how many participants in the 17th round represented the cumulative participants, we have to find how many participants were actually total. So we're going to use the same formula and then plug in all your values, and you're going to get 193,710,243 total pyramid participants. You have to divide your new recruits of the 17th round by the total participants, and the new recruits of the 17th round represent 66.7% of the cumulative participants. At Vons, you stick oranges into a square pyramid. You notice the pattern of the top 3 layers has 1 orange, then 4 oranges, then 9. This continues for 15 layers. So what we have to do is find the total oranges. So we're going to find a summation notation. So the top number 15 is how many layers we have, and then the formula is I squared, and you start off your I with 1. So you just go 1 to 15, and then you find out that you have 1,240 total oranges. Calculate the total using the sum of squares formula. So once you plug in all of your values, you get the same number. Alright, so on January 1st, you deposit $6,000 in a retirement account that pays 7% annual interest. You make this deposit each year on January 1st for the next 32 years. And we're trying to find out how many money you have in your account immediately after you make your last deposit, and the total after 32 years. So you're just going to find the pattern, and we find out that this is a geometric series. And so for each year, you add the 7%, and that's how you find your pattern. And then so after 3 years, you have $1,289.40. So to find the total after 32 years, you have to use your geometric series formula, plug in all your values, and then for your total after 32 years, you have $308.93. Alright, so how much was added to your retirement account in just the last year? So from the 31st year to the 32nd year. So we're going to use the same formula we've been using. And then once you plug in all your values, you get $48,870.68 for your total added in the 32nd. For how much gets added to your bank account every year, we're going to use AN equals AN to the power of -1 times 1.07 plus 6,000. So the 1.07 is a 7%, and 6,000 is the amount getting added each year. So I'm going to explain why my account grows the most and why. It grows the most in the last year because it gains the most compound interest. And this is just a picture I posted on Instagram because of my birthday that just passed. Yay, turn up.